So now we're going to talk about composite reflection over intersecting lines. So as discussed in the previous video, composite reflections would be more than one reflection in a row. And in this case, over intersecting lines means that the two lines must cross. So let's take a look at a couple of examples so we can kind of figure out what's going on. Now we are going to be talking about two transformations, that is two reflections. So the first reflection that I'm going to do here is a reflection over this line, which is y equals x, of this object, which, as expected, creates that. And then I'm going to do another reflection, in this case over the y-axis, on the image. That makes it a composite because we're doing one, then the other. So remember, from a notation standpoint, we're looking at this being A prime, and we know that that A prime is 3, 4, because it's a reflection over the line y equals x. That was our first one, right? And then it was, of course, a reflection over x equals 0, which is the y-axis. So we're doing a reflection over y equals x, and then a reflection over x equals 0. Now, this becomes A prime. Of course, we know that this is B prime, which is 1, 5, and then C prime, which is 1, 4. And then when we do the composite, let's do that in a different color, we know that this is going to become C double prime right here, and that's going to be at negative 1, 4, B double prime, because it's the second, and that's going to become negative 1, 5, and then A double prime, which is going to become negative 3, 4. Now the interesting thing is that the original A becomes A double prime, which is negative 3, 4. 5, 1 becomes B double prime at negative 1, 5. And C becomes C double prime. This is after both of these reflections. And the point here is, that would be negative 1, 4. To go from one to the other, what happened? In other words, to go from C to C double prime, or A to A double prime, we took x, y, the original, and what? Well, we flipped it, and we took the original y and made it the opposite sign. Now, if that looks familiar, it should. In fact, that ends up being a rotation of 90 degrees counterclockwise. So what does this imply? It implies that if we do a reflection over x equals 0 following a reflection over y equals x, it's equivalent, the same, as a rotation of 90. Now, if you don't believe the formula, we can do a quick confirmation by doing a rotation centered the origin. And we already have positive 90 degrees, and we're going to apply it to that. And look, perfectly match up, which verifies that the composite of two reflections over two intersecting lines ends up being a rotation. Now, in particular, if you think about how this worked, we took y equals x, and that was the one we were going over first, and then x equals 0, that we were going over second, which means we did this one first and then this one second. So if we rotate this line on top of that line, that's the direction of the rotation, thus the counterclockwise. And we've talked about this before, this is at a 45-degree angle, which means that this is a 45-degree angle, meaning there's a 45-degree angle between the two, and guess what 2 times 45 is? That tells us the magnitude or the amount of the rotation. So, to sum up, the result of a composite reflection over two intersecting lines is a rotation. The amount of the rotation is 2 times the angle between the 2 intersecting lines of reflection, and the direction is the rotation it would take to cause the first line of reflection to match up with the second. That's pretty much it. Let's do a couple of examples just with, so let's do this. Let's say we wanted to do a reflection over x equals 0. We'll just use following reflection over y equals 0. In other words, we're going to reflect over the x-axis, right? And then we're going to reflect over the y-axis. And let's pick a point. Let's say we're going to do that on 6, -3, right? So we would do the reflection over y equals 0, aka the x-axis, which would cause the y value, the x to stay the same, the y value to become the opposite, so it becomes 6, 3. Then we do a reflection x equals 0, which would cause, well, that's the y-axis again, so that would mean that the x would change sign, and the y would stay the same. So the net effect is that we get -6, 3. So thinking about that in a couple of different terms, if this were x, y, the original, then the final, double prime, right, is just the opposite of the original. So we know that's a rotation based on what we just talked about. What type of rotation? That'd be a rotation of 180 degrees. Here's y, or here's another way to think about this. Here's y equals 0. Here's x equals 0. If we reflect over this first, and then this second, then we're going in this direction. And what's the angle between? 90 degrees. 90 times 2 tells us how much of rotation, and we know that it's counterclockwise, okay? Now it turns out in this case, if we went this way, it would still be 90 degrees counterclockwise, but we also know that for rotations at 180, it doesn't matter, okay? So let's take a look at one more example. Let's make a prediction just on the lines. What if I were to reflect first over the line, whoops, let's back that out of there, there, and there, okay? So this is the line y equals opposite x, right? So let's say we're first going to reflect over that. That'll be our first reflection. And then we're going to reflect over x equals 0, okay? So that would mean to go from one to the other, we'd be turning this direction, aka clockwise, and that would be 45. So we would expect that to be a rotation of -90, right? Another way is to go from this first line to this second line could be thought of as going this way, which would be counterclockwise, but the angle would be 45 plus 90, which is 135 degrees. And 135 times 2 is 270, so that could be a rotation of 270 counterclockwise. We know that these are both equivalent, so that kind of makes sense. And based on this, just knowing that we're doing a reflection over y equals opposite x first, and then a reflection over x equals 0, we could predict that xy would become y opposite x, because we know that this has that formula, because we know in the end that composite reflection ends up being the rotation.